So this problem says 50 grams of water at 20 degrees Celsius is heated until it becomes vapor at 100 degrees Celsius. Calculate the change in entropy of the water in this process. Okay. So what are you doing? You're taking a bunch of water, 50 grams. First, what you have to do, you have to heat it from 20 degrees to 100 degrees Celsius. And then from 100 degrees Celsius, you have to vaporize it to at 100 degrees Celsius. Okay. All right, so change in entropy is, so while you're heating it, okay, so let me, you're heating the water. Let's see what is the change in entropy while you're heating the water. So this is the small change in entropy for this small amount of heat added while you're heating the water. Okay, while you're heating the water, the temperature is rising, and so you'll have to take that into account. Okay. So this is equal to the mass of water times the specific heat of water times the change in temperature. Okay. So as you're going from 20 degrees to 100 degrees, you got to sum up all these little pieces. And that's what we're going to do. C dt. So this is the change in entropy as you heat the water, as you're going from 20 degrees Celsius, which is 293 Kelvin, to 373 Kelvin. Okay. So the change in entropy for that process is mass of the water times its specific heat, and the integral of that is log T, and you're applying these limits. So that's the change in entropy while you're heating. Okay, what we'll call it is, we'll call it process 1. Then you vaporize the water. So delta S2. Now, thankfully, that process happens at the same temperature. That process happens at a constant temperature, M LV divided by T. Okay, well, so we'll put the numbers there. So that's delta S2. So the total change in entropy is delta S1 plus delta S2. This is the change in entropy while we're heating the water. This is the change in entropy while you were vaporizing the water. Okay. So, okay, let's see. What is entropy? When entropy increases, what happens? I'm sorry? Disorder increases. So while you're heating the water molecules are getting faster. When you make it into steam, when you convert it into steam, they're going further and they're going fast as well. Which number do you think will be bigger, this one or this one? I'm sorry? S2. Okay, when it becomes steam, there's a lot more disorder. And you'll see that that number is bigger. Okay, so we'll calculate them separately. Okay. All right. What is S1? MC logs 373 divided by. All right, mass is 50 grams, and I will use mixed units. Specific heat of water is, you can look it up, 4.186 joules per gram per Kelvin. Log 373 divided by 293 plus mass is 50 grams again. Latent heat of vaporization is 540 calories per gram. And 1 calorie is 4.18816 or 186. Okay, so I'm mixing up units, but you guys can look it all up. So 50 grams, 540 calories, 4 point, oh, I need more space. grams, 540 calories into 4.186 joules per gram. Okay, and that's latent heat of vaporization divided by 373 Kelvin. All right, so let's see if our friend there was right. So, okay, so joules per Kelvin is what we get. 50. All right, so you can see it right here. The 4.86 is a common factor, 50 is common, and essentially this is 500 times greater. No, okay. Oh, well, this is roughly 1. So, Anyway, you can see that the change in entropy is 6 times greater during vaporization. Okay. So the total entropy change, of course, is 353.5 joules per Kelvin. And the greatest entropy came from during phase change.